Stand next to a chimpanzee, and you look like someone stopped drawing the fur halfway through. Same basic body plan, same warm blood, same need to survive cold nights, sharp branches, biting insects, and terrible weather. Yet the chimp gets a full coat, while you get a light dusting on your arms, a few dramatic patches, and a scalp that refuses to follow the rules. So why did humans lose almost all their fur? The easy answer is that Africa was hot, fur was warm, so evolution deleted it. Clean, simple, also incomplete. Lions live in the same heat with fur. Zebras cross open plains wearing striped jackets. Even baboons stay hairy without melting into the dirt. Fur can block sunlight, protect skin, and slow heat from reaching the body. Losing it was not automatically an upgrade. It was a trade, and what humans received in return may be one of the strangest superpowers in the animal world: the ability to become soaking wet on purpose. First, a small correction. You are not truly hairless. In a 2018 study called Comparative Evidence for the Independent Evolution of Hair and Sweat Gland Traits in Primates, geneticist Yana Kambarov, anthropologist Daniel Lieberman, and their colleagues compared skin from humans, chimpanzees, and macaques. They found that humans still have a chimp-like density of hair follicles. The major difference is what those follicles produce. Instead of growing a thick coat of long fibers, most of our body produces tiny, fine hairs called vellus hairs. Evolution did not bulldoze the forest. It trimmed most of the trees into grass. At the same time, human skin became packed with eccrine sweat glands. These are the small glands that release watery sweat directly onto your skin. Kambarov's team found that humans had, on average, about 10 times the eccrine gland density of the chimpanzees and macaques they examined. That was not a minor adjustment. It was a complete renovation of the cooling system. To understand why that mattered, picture an early human moving across a hot, open landscape. The sun is high, shade is limited, food and water are scattered. A furry animal can cool itself by resting, finding shade, licking its coat, or panting. Panting works well until the animal needs to run hard. Fast-moving muscles create heat, while breathing must handle both movement and cooling. Humans took another route. We spread sweat across a mostly bare surface. As that sweat evaporates, it carries heat away from the skin. A thick coat would hold moisture near the body and reduce the airflow that makes evaporation effective. Shorter, finer hair allows sweat to reach the surface and vanish into the air. It is biological air conditioning, except the electricity bill is paid in water and salt. Anthropologist Nina Jablonski has spent decades studying the evolution of human skin. Her research argues that major fur reduction probably occurred in early members of the genus Homo, when our ancestors began traveling farther through hot environments to find food and water. The precise date remains uncertain because skin and hair almost never fossilize. Bones can wait around for millions of years. A prehistoric armpit cannot. Jablonski places the major shift roughly 1.5 to 2 million years ago, during a period when human bodies were becoming better suited for sustained activity in the heat. That timing connects with another famous piece of research. In 2004, anatomist Dennis Bramble and Harvard anthropologist Daniel Lieberman published Endurance Running and the Evolution of Homo in the journal Nature. They argued that around 2 million years ago, the human lineage developed a package of traits that made sustained running unusually effective. These included longer legs, spring-like tendons, stronger joints, a ligament that helped stabilize the head, and an efficient cooling system. Humans are terrible sprinters. Put Humi beside a cheetah and the race ends before he finishes tying one sandal. But over a longer distance, especially in hot conditions, humans can keep moving after many animals must slow down to avoid overheating. This does not prove that one particular hunting method caused humans to lose their fur. Evolution rarely signs a confession. Still, the combination makes sense. More movement created more heat. More sweat removed more heat. Less fur allowed that sweat to evaporate. Each change made the others more valuable. Cooling is the leading explanation, but it may not be the entire story. In 2003, evolutionary biologists Mark Pagel and Walter Bodmer published a paper with the wonderfully direct title, "A Naked Ape Would Have Fewer Parasites." Their idea was that thick fur gives ticks, fleas, lice, and other unwanted passengers a giant apartment complex. Reduced body hair could make parasites easier to see, remove, and avoid, especially as humans began sleeping close together and sharing living spaces. Fewer parasites could mean fewer bites, fewer infections, and fewer evenings asking a friend to inspect a suspicious moving dot near your shoulder blade. This parasite explanation is plausible, but it remains a hypothesis rather than a final verdict. And here is the clever twist. Humans did not erase body hair completely. In 2011, researchers Isabel Dean and Michael Sivajathy tested whether fine human body hair helps detect bedbugs. Their study, Human Fine Body Hair Enhances Ectoparasite Detection, found that bedbugs took longer to search across unshaved arms. While people noticed the insects more often when their fine hairs remained, our tiny hairs may work like motion sensors. Thick fur gives an intruder somewhere to hide. Completely smooth skin gives you less warning. Fine hair may be evolution's awkward middle solution, a terrible blanket but a decent alarm system. Then there is the question sitting directly on top of your head. If bare skin is useful for cooling, why keep a thick patch of hair right above the brain? Because the scalp faces the opposite problem. When you stand upright, the top of your head receives intense sunlight. In 2023, anthropologist Tina Lasisi and a team including Nina Jablonski published Human Scalp Hair as a Thermoregulatory Adaptation in the Proceedings of the PEDINS, National Academy of Sciences. The researchers placed human hair wigs with different curl patterns on a heated mannequin beneath simulated sunlight. Scalp hair reduced incoming solar heat. Tightly curled hair provided the greatest protection, while reducing how much sweat was needed to prevent the scalp from heating up. The human design was not simply remove the hair. It was more like clear the radiator but leave a sunshade above the control center. That also explains why this story connects with the evolution of skin color. Once thick fur was reduced, skin near the equator faced powerful ultraviolet radiation. Nina Jablonski and geographer George Chaplin showed that dark, melanin-rich skin evolved as protection in high ultraviolet environments. Melanin acts like a natural shield, helping protect important molecules and tissues while exposed skin performs its new cooling job. Fur reduction, sweating, scalp hair, and pigmentation were not separate costume decisions. They became parts of one complicated survival system. Scientists still do not agree that every detail has been solved. Sexual selection may have influenced how hairlessness spread or remained common. Parasites may have added more pressure. Body size, upright walking, changing climates, and social behavior may also have contributed. The safest conclusion is not that humans lost fur for one magical reason. The strongest evidence points toward heat control as the main engine, with several other pressures helping shape the final pattern. Evolution did not plan a naked ape in advance. It kept modifying a primate body until a strange combination worked. Fine hair instead of thick fur, a dense network of sweat glands, protective scalp hair, and skin adapted to sunlight. That combination helped our ancestors remain active when the landscape was hot and the nearest meal did not include delivery. The price is that modern humans now require clothing, shelter, sunscreen, and an emotional support blanket whenever the air conditioner becomes slightly aggressive. But the same bare, sweaty skin that looks fragile beside a furry animal may have helped humans travel farther, search longer, and survive conditions that forced other animals to stop. So the next time sweat destroys your shirt, remember that your body is not failing. It is using an ancient cooling system that may have helped make the human story possible. Now tell me this, if you could bring back full-body fur, would you take it, or would one hot shower immediately change your mind? Send this to the friend who complains about body hair like evolution personally targeted them, and subscribe to Humanly Weird, where simple drawings uncover the strange science of being human. Humans are weird. Here's why.